This video is going to be on PID using machine learning. This is going to be a series of videos from time series till LSTM, that is going to be the basic of PID. Now, as you can see on the screen, actually data which are separated in time sequence or in time stamps in the x-axis look like this, and this is called a time series data. Now, in order to have a model to be built, we will call it a univariate MLP model first. Univariate time series are a data set comprised of a single series of observations with a temporal ordering. It looks like that, like 10, 20, 30 up to 90. There are 9 datas, and the model is required to learn from a series of past observations. It's like a temperature data or whatever, actually, to predict the next value in the sequence. You can see you'd like to know what would be the next data after 90. So this process is divided into 2 parts, and the first is called data preparation and second is called the model MLP model, multi-layer perceptron model. So I begin with the data preparation. So before any series can be modeled, and it must be prepared, that is called data preparation. And the model will learn a function that maps a sequence of past observations as input to an output observation. A function is going to do this. And consider an example of a time series function which we discussed. We can divide the sequence into multiple inputs and output patterns called samples. Here in our case, 3 timestamps are grouped together and they are used as the input, and 1 time step is used in output for the 1-step prediction that is being learned. Example of a univariate time series as a supervised learning problem looks like that. You can create XY data, and X is grouped into 3 datas and Y is one single output. You can see 10, 20, 30, then 40 is the output, then again 20, 30, 40, 50 is the output, like that, so on, so on, so on you can go. And the complete program looks very simple. This is a 1 single page program. The raw sequence looks like that. Actually, it's a simple array. And n steps you write as a constant 3. And the program looks like that. X comma y is equal to a function is being called. To do this, that is called split sequence. And you pass in this raw sequence from here and the number of steps here. And at the end, it simply prints out. Actually, it prints out X and Y values. So that is what the output would look like that. So this is called the data preparation. And in order to perform this, the split sequence function looks like this. And it uses a simple library called NumPy, which most of you must be familiar, and you can import an array from there, and from there, as you can see in the yellow color, actually that is where the function begins. I'm writing a function called split sequence with 2 arguments. The sequence, that is a real sequence of data which is coming in, and steps, in our case it is 3. So there are 2 lists, X and Y. X is the input combinations and output will be the output. So, for I in range, all the sequences, number of sequences, in our case it will be 9 datas. So it will be 0 to 8. So, it creates a variable called n(ix), which is equal to I plus n steps. So when I is equal to 0, it will be 3. When I is equal to 1, it will be 4. When I is equal to 2, it will be 5. This is creating an offset by this. So now whenever the sequence, the I is equal to 6, that probably is towards the end actually. That is because we have only 9 data and groups of 3. Whenever it exceeding that value, it has to come out break. So sequence X will be basically from the I value till end of this constant, which will be going on vary for 0, 1, 2, 3 up to 6. I will be vary. So you can see that X will have 3 combinations and Y will be the output one single value. You can see the comments below. So ultimately you will append the sequence X into final X and also append Y, and you will simply return 2 different arrays X and Y. That is the function. So finally, as I explained earlier, the entire program calls this function here split sequence. Number of steps you define, any number value, in our case it's 3, and this is basically to summarize or print out the data. So the output looks like this. This is called the data preparation has been done, and this is how you do this. And we will have the next videos in series till LSTM PID, so a lot of basics have to be learned. Okay, see you in the next video.